Okay, so we have related rates, and we need to review implicit differentiation just a little bit in order to actually do the related rates problems. So we did something like this in class where we're asked to differentiate maybe x squared plus y squared is equal to 7. So we know that the derivative of x squared is 2x, and we just differentiated x with respect to t. Then we'll have 2y, we just differentiated y with respect to t, and on the right hand side we have 0. So that's it. We can't solve for dy, well, we don't have to solve for dy dt. We weren't asked to. And we weren't asked to solve for basically anything here, just differentiate. All right, r squared h minus 3r plus 2h is equal to v. So in this case, we're going to have the product rule. So we'll have r squared times the derivative of h times the derivative of r minus 3 times dr dt plus 2 dh dt is equal to dv dt. Okay, so here's a related rates problem. A pebble is thrown into a pond, causing concentric circles to ripple outward. And that's what that looks like. So we have these circles radiating outward. The radius of the outer ripple is increasing at 3 feet per second. And we want to know when the radius is 8 feet, at what rate is the area of the disturbed water changing? So the area of the disturbed water, that's what we're trying to figure out, how quickly it's changing. So we know that the area of this thing is pi r squared. And so that's what we probably should start with, but we want to write down what's given to us. We know that the radius is 8. We know that dr dt is 3 feet per second. That's the rate of change of the radius. And so we want dA dt, the rate of change of the area, when r is 8. And so all we have to do here is differentiate the area equation and then try to plug in what we know. So if we look at it from overhead, this is what's happening. The rock hits, we have these circles radiating outward, and basically we stop time when that outer circle is equal to 8 feet. And at that specific point, that's when we want to know what's happening with the rate of change of the area. So if we differentiate this thing, a is equal to pi r squared, we're going to have dA dt is equal to 2 pi r dr dt. And so all we have to do is plug in what we know, which is r is equal to 8 and dr dt is equal to 3, and we're left with 48 feet per second squared. All right, secondly, a UFO is flying at an altitude of 6 miles. Its flight path goes directly over a radar station. If the distance between the UFO and the radar station is decreasing at 400 miles per hour, what's the speed of the UFO when it's 10 miles from the station? Okay, so a lot is given to us here. We want to try to draw a picture to see what's going on. So we have a radar station, and we have a UFO that's going to fly over it. So we're told that this UFO is going to have to stop when it is 10 miles from the station, so right here. And if you think about what we have there, it's going to be a triangle. So we have S, which we can call the distance from the UFO to the station. We have X, that distance on the ground, and then we have 6, which is the altitude. So remember that the distance S is changing at negative 400 miles per hour. So that's going to actually be our ds dt, the rate of change of S. So we can try to solve a little bit here. We do know that if S is 10, the distance between the UFO and the station is 10, X must be 8 if we use the Pythagorean theorem. And now we want to find dx dt if S is 10 and X is 8. So again, remember, we're looking at one single moment that happens as the UFO passes through the sky. That moment is s equals 10, x equals 8, whatever else we can come up with. So by the Pythagorean theorem, x squared plus 6 squared is equal to s squared. And that's the equation of our triangle here, so we want to differentiate it. 2x dx dt equals 2s ds dt. Now, remember what we're given here. We're given s, x, ds dt, and we're trying to find dx dt, which is the speed, the velocity. So if we solve for dx dt and then just plug everything in that we know, 10, 8, negative 400, and we simplify, we get negative 500, and that is miles per hour, or whatever unit we're usually going to be given, we'll put here. And it's moving to the left, so we have negative 500 miles per hour. That's the velocity, but the speed is just the absolute value of that. So 500 miles per hour is what we're looking for.